So what is the name of this compound? We have to write the name of the cation, and then we have to write the anion. Okay. So let's try to figure out what is the name of these compounds. Okay, this ligands are named first, as you know. Pentamine chloride. What is the charge on cobalt? Let it be X. Cl is -1. NH3 is 0. There are two Cl outside the square bracket, -2. And the sum total is 0. S X equal to +1 +2. That is going to be +3. So pentamine chloride of cobalt 3 and chloride I will write, right? Is it clear?
Yes, sir.
Okay. Or if the reverse is given, in the reverse case, you will be provided with the name and you are asked to draw the compound. Got it? So that reverse examples also are a good way to practice the naming, IUPAC naming, right? So let me write one of the reverse example where the name is given and you have to mention the formula, and that is sodium tetrathiocyanato cobaltate 2. So how am I going to write the formula? Just write quickly and just reply it to me in the chat box. Jaslin, Aisha, I hope both of you can see the question.
Yes, sir.
Okay. So cation sodium is clear. That we know. And anion also we know. It is made up of cobalt, right? So how we are going to do it? We are going to put this whole thing in the square bracket, and we need to write the cobalt first metals by writing the formula. This need to be done as we have discussed in the previous class. Got it? And tetrathiocyanate. Okay. So the total charge is -2, and this is going to be the formula of the complex. Is it clear? I
Yes,
shall
sir.
just
Yes, sir.
so just be careful about the charges. First decide the charges, then write the formula, complete formula, including the cation. Let me uh, take another example. One more example. Potassium hexacyanide of ferret 3. So how we are going to write the formula? Just tell me. The cation is clear to all of you.
Yes, sir.
That is
The
potassium.
potassium will be out of the bracket.
Yeah, that is out of the bracket, and bracket has iron, ferrate. Iron is in +3, and there are 6 Cn minus. So that makes it very clear. FeCN6. Got it? Metal should be written first, and +3 -6. The charge is going to be -3. So I'm going to put K3. Okay. So this is going to be the formula, right?
Yes, sir.
NiCO4. Cu is a neutral carbon monoxide neutral complex. Okay. So it is total charge is 0, Cu is 0, so nickel must be 0. And there is no cation involved in this naming. So this is going to be the name tetracarbonyl nickel, right? So now let's start with the bonding part of the coordination compound. Actually, in NCERT, the bonding part is given before this. Okay, at the starting itself. So just we need to first get us familiarized with the basic terminology. Then we should get into the bonding part. So now I'm going to, because once we are now we are familiar with the basic things, we know what are ligands, we know what is the single metal atom, we know the oxidation state, okay, the charges, okay, we know how many bonds, what is the coordination number. Okay, so now we know a lot of things. So now we can proceed to the theories of bonding. So the first one is the Werner theory of coordination number. And this is basically the most earliest work done by Werner on the coordination compounds. So what he did was he took cobalt chloride and he reacted with ammonia molecules. And he saw the formation of different types of complexes between them. And by studying those different complexes, he came to uh, a certain conclusions, and those conclusions are come under the heading of Werner's theory of coordination compound. Basically, it is trying to explain us how the bonding is taking place in coordination compounds. So let's proceed. First, let's proceed with the compounds which Werner formed. So he reacted ammonia and cobalt chloride together. And he observed the formation of COCl3. Got it? How the Werner represented it?
Yes, sir.
Werner represented it in this way. This was the representation of Werner. First, let me draw it. And there are some details which need to be discussed. There are 6 NH3 connected to the cobalt, and I'm connecting them with the solid lines. And there are Cl also, 3 Cl minus. Those Cl minus were connected by dotted lines. Both are equal. One is a formula, another is a structure. And what these dotted line and solid line indicating, as per the Werner theory, the solid line indicated the secondary valence, and the dotted line indicated the primary valence. Okay. Secondary valency and primary valency were the two types of terms or the types of bonding which were indicated by Werner in his theory. Okay, and as you can see, the 6 ammonia molecules are satisfying 6 of its secondary valencies and 3 Cl minus are satisfying its primary valency, which is equal to its charge. The primary valency corresponds to the charge of the metal ion. Is it clear? So all of you can know in present day context what it means. This is secondary valency. Representing the bonds between the cobalt and ammonia. These are the covalent bonds or the coordinate covalent bonds. Got it? And when you try to put it in water, what happens?
They dissociate into ions.
Yeah, dissociate into ions. And how they dissociate? This whole thing with the cobalt and 6 ammonia molecule remains intact. And so, and the evidence for this is this can be given when you react with silver nitrate. You are going to get 3 moles of AgCl as white precipitate. Is it clear?
Yes, sir.
So what is the primary valency of the cobalt? It is 3. In this case, or I should write it here. And the secondary valency is 6. You can see the 6 ammonia molecules being connected to it. So this is how, by measuring the mass of AgCl, by knowing its weight, he measured how many moles of AgCl were found. And he came to know that there are 3 Cl minus which are getting ionized from the moles of 3 moles of AgCl formed upon addition of AgN. Next is he not only studied one compound but all series of compounds formed by cobalt chloride and ammonia molecule. The other molecule is this one. The other reaction, it ended up with COCl3.5NH3. The primary valency is still the +3. The secondary valency, that is still 6. But you may wonder that there are only 5 NH3 molecules. So how come the 6 bonds are there? So that can be explained by the structure which was given by the Werner, that was the cobalt, 6 bonds. Out of these 6 secondary valencies, 5 of them are NH3, represented by solid lines. That is clear. You can very well make out, but the problem is what happened to that fifth bond? Who is satisfying it? Okay, who is getting it satisfied, and to whom this cobalt is connected? One thing is for sure, that there are only 2 types of molecules, either the ammonia or the chloride ions. So in this case, the cobalt is connected to 5 NH3 and 1 chloride ion. Because this is a negatively charged ion, it is going to satisfy its charge also. Cobalt is +3. So chloride is going to satisfy the charge, got it? And it is going to satisfy the bond also at 6 bond. Clear? And what about the rest
So
of the
could you
2
repeat?
Yes, yes. So primary valency is 3 and secondary valency is 6. What the primary valency means? It represents the charge of the metal ion. Okay. And how it is satisfied? It is satisfied by oppositely charged ions, anions, right? So the primary valency was 3. Okay, I need 3 Cl minus ion, you can say, to satisfy this +3 charge. I need 3 Cl minus ions. Got it? Is it
Yes,
clear?
sir.
But secondary valency is still 6. So secondary valency, the covalent bond, coordinate covalent bonds, which we call today, Werner called them as secondary valencies. Okay. So that covalent bond, there are just 5 NH3. How come the 6 covalent bonds are going to get formed? The answer is that 5 NH3 molecule will be making 5 covalent bonds, right? And one of the Cl minus, okay, it is making covalent bond also. So it is fulfilling 2 purposes. One is because it is minus, so it is going to neutralize the charge of the cobalt +1 charge is neutralized by 1 Cl minus, and it is linked in a different way. It is linked through the covalent bond also. So I should say so the lower Cl minus, I have represented by both the types of bond together. One is the permanent line, that solid line that represents it is connected by covalent bond. It is satisfying secondary valency. And there is also a dotted line, which indicate that it is also satisfying the charge of cobalt, which was +3. So one of the +3 charge got neutralized by one Cl minus. Is it clear or not? Any doubts in this? Aisha, Jaslene? So
Yes, sir.
six bonds were there, 6 secondary valencies were there, but there were only 5 NH3. So one Cl has to play two roles. Okay, two different roles. It must form a bond also, covalent bond also. It must satisfy the secondary valency also. But being a negatively charged ion, it will also neutralize the charge. So it will simultaneously satisfy primary valency. Got it? And when this, so this is both are same. One is the formula, another is the structure. I am writing them in Werner's representation, and when you put them in the water, they will dissociate. But now, Aisha and Jaslene, can you tell me how many ions will get dissociated? How many ions will get dissociated?
2 ions. Hmm?
This whole thing will get dissociated cobalt. And how many? Yes, 2 Cl minus ions only will come. Why not 3? Why not all the 3 Cl minus ions will come out? Because one of the Cl minus was forming a covalent bond also, was satisfying a secondary valency. Got the point?
Yes, sir.
So that we know will not get ionized. Only the chloride ions which were satisfying the primary valencies only, they were ionized. And Werner came to know this by reacting it with silver nitrate, which led to the precipitation of 2 moles of AgCl. Got it? Is that clear?
Yes, sir.
Yes, sir.
Right. So 2 moles of AgCl will from that Werner analyze that okay, this may be happening. He also found one more type of compound, or in fact, 2 more type of compound formed by cobalt chloride and ammonium. In this case, only 4 NH3 molecules were being used. Okay, so what may be happening? The primary valency is +3 or 3. Okay, and the secondary valency is still the 6, but there are only 4 ammonia molecules. So 2 of the Cl minus ion should simultaneously satisfy the primary as well as the secondary valencies. So you can have cobalt. Got it? I will write it NH3, 4 NH3 I'm going to write it. Two Cl minus I'm going to write, but I will show 2 types of connections together. One is through the solid line, another one is through the dotted line. Solid line as well as the dotted line together. So what this is representing that 2 of the Cl minus ions are being connected to the cobalt through primary and secondary valencies both together. Means they are connected by covalent bond. They are also satisfying the charge of the cobalt because they are themselves negatively charged. and one Cl minus I'm going to put it. I can put them anywhere. I put it anywhere, right? So this is going to be the representation, Warner representation. And when you put it in water, it is going to be like this. Only one ionizable Cl will be there. And how Warner came to know about it? By adding AgNO3. Only one mole of AgCl was precipitated. The next case is in this case also we have the primary valency equal to 3, secondary valency equal to 6, but there are only 3 ammonia. So what may be happening? Tell me quickly. Yes, Lynn, Aisha, yeah.
So it will bond with cobalt.
Yeah, 3 ammonia. Can ammonia satisfy the primary valency? Yes or no? It cannot satisfy because it doesn't have a negative charge. Got it?
Yes.
It is neutral. It is neutral. Primary valency means this is +3 charge. And who is going to satisfy it? Cl. So there are 3 Cl minus to balance that +3 charge or satisfy the primary valence. But what about the secondary valencies? Secondary valency is 6. Got it? So who may be forming those 6 bonds? What could be the explanation? Aisha and Jasleen, tell me. So what could be the explanation for the formation of those 6 bonds? There are only 3 NH3 molecules. So who else may be forming the rest of the 3 bonds?
The chlorine ions.
Yeah. So chlorine ions or the chloride ions are fulfilling 3 of the chloride ion. All 3 are fulfilling both the purposes, right? What are they? They are forming the bonds and they are also satisfying the +3 charges. Got it? Is it clear?
Yes, sir.
So how many of them will be ionizable? Will all the 3 chloride ions get ionized?
Only 2.
2 or none of them? In the last case. None of them will ionize. Are you getting my point? Justine, are you getting? Aisha?
Yes, sir.
So why none of them? Nobody will ionize. Nobody will come out. What's the reason? The reason is they are connected by covalent bonds. They are satisfying the secondary valence. Okay, so they can't. They are held very tightly, and they will not be ionized. So, no ions will be formed. No ionization will happen. We know all the three chloride ions are connected by covalent bonds, or they are satisfying secondary valency, so they will not ionize. No PPT of AgCl is formed. Is it clear or not?
Yes, sir.
So let me summarize. Why the three Cl minus couldn't come out in the above example? What explanation will you give?
Because they fulfill the secondary valency and they're
They were
like
connected
tightly
by,
bonded,
yeah, they
covalent
were
bond.
connected by bonds, covalent bonds or secondary valency, which would be, and they will not ionize. Okay, secondary valencies are non-ionizable. Sorry, excuse me. So, primary valencies are ionizable and they are satisfied by. Actually, it is what? Charge of the metal ion. Who can satisfy primary valence? So are these both the points clear?
Yes, sir.
Leslie, is it clear?
Yes, sir.
Primary valency can be satisfied by ions only. Secondary valencies can be satisfied by neutral molecule or by ions both. Examples are these three chloride ions are satisfying both, but they are non-ionizable because they are satisfying secondary valencies. Same is the case here also. These two chlorides are non-ionizable, that chloride is ionizable. That is satisfying primary valency. This is satisfying both primary and secondary valencies, and the two chloride ions, they are satisfying the primary valency only. So only those two are ionizable. And all the three chloride ions are ionizable in this case. Is it clear? And
Yes.
on this actually, they will, upon ions of, they will, and upon putting in water, they will form ions, and accordingly you will form the precipitate of AgCl. So the moles of AgCl precipitate will be equal to the number of, or the moles of chloride ions, okay, separated out. Got it? So basically, what are the points of Werner theories? Postulates of Werner theory. Can you tell me? So first, if they ask you to write the postulates of Werner theory, so first you are going to write the types of valencies which the Werner told us. What are the types of valencies which Werner told us?
Primary and secondary valence.
Yeah. Werner first postulate of the Werner theory is about the type of valencies which a metal ion can exhibit. How many types of valencies a metal ion can exhibit? We have seen about. Metal ion can show how many different types of valencies? Two different types of valencies. Got it? And what are those two different types of valencies? What are they?
The primary and the secondary valence.
Yeah, primary valency and secondary valency. Next point. Who can satisfy them? As I told you about, who can satisfy them? Primary valencies can be satisfied by whom? And the secondary valencies can be satisfied by whom?
The ions
Who
only
ions
for
can
primary.
satisfy?
The primary valence.
Yeah, primary valencies can be satisfied by ions only. Got it? I'm writing in short form, but in bold, never write it like this. Okay, write the complete statement. Got it? Otherwise, the marks will be deducted. Is this clear? When the ions are
Yes.
going to satisfy the secondary valency and primary valency both, that if there are no sufficient molecules which can satisfy the secondary valency, so then ions are going to come in place of the secondary valency also, and they will satisfy the primary valency. Okay, so first find the charge. Cobalt is +3. Okay, and 3 Cl minus are there, that is already we know. Okay, and but there are only 3 NH3. So how that 6 valence is going to be satisfied? So we are going to put the 3 Cl minus uh, to for secondary valencies also and for the primary valencies also. Got it? And that's why we have put the two lines, the solid line and the dotted line, to represent that the chloride ions in this case, because there were not enough NH3 molecules to satisfy both the type of ions. Got it? Is it clear or not? So primary
Yes, sir.
valencies are satisfied by ions, and they are ionizable. Secondary valencies are satisfied by neutral molecule or ions. Okay, and they are non-ionizable. Jasleen, is it clear to you? Any doubt?
No, sir.
And next point is, can you tell anything about the arrangement of these primary valencies and the secondary valencies? The arrangement around the central ion, the metal atom or ion. So primary valencies, this arrangement. So secondary valencies have fixed arrangement. Got it. The secondary valencies or the secondary linkages, okay, one and the same thing, have the fixed arrangement around the central metal atom or ion, and these arrangements are known as coordination polyhedron. Got it?
Yes, sir.
So that coordination polyhedra is mentioned in the square bracket. And so whatever is in the square bracket, that has fixed arrangement or geometry around the central metal atom or ion. So how many different types of coordination polyhedra we are having? Suppose if metal is connected to two, if it is having two secondary valencies, it is going to be having two uh, groups connected to it, and they will be in a linear manner. Got it? In order to minimize the repulsion. I'm also writing their shapes. Got it? So, and suppose if the metal is having three ligands, the secondary valency is 3, and the coordination polyhedra is having the metal and the 3 ligands connected to it. This is trigonal planar. The arrangement is known as trigonal plan. And if there the coordination polyhedra has 4 groups, but the secondary valency is 4, it could be tetrahedral or square planar. Got it? So these could be the geometries or the arrangement of the coordination polyhedra. When it will be like when it will be square planar, when it will be tetrahedral, that we will see. Got it? Next is suppose if you have 5 groups. Secondary valency is going to be 5. And this whole coordination polyhedra, I have not written the groups. Okay, just written the lines. Okay, solid line. Groups can be NSC, Cl, okay, whatever the ligands are. I'm just writing the name of the arrangement in which the coordination polyhedra is present. So this is very important for you guys. Okay. These two. And the one which I'm going to write now. If the secondary valency is 6. So coordination polyhedra will have the 6 groups connected to metal. Okay. And this whole arrangement, geometrical arrangement. Any idea what is going to be the name of the geometrical arrangement?
Octahedral.
Octahedral. Yes. So octahedral, this is also very important. So these three coordination polyhedra we are going to very frequently encounter in our questions. Tetrahedral or square planar. That is if the secondary valency is 4. 4 groups are present within a square bracket, or 6, which is 6 groups, 6 ligands are present within a square bracket. The coordination polyhedra, the shape of it is known as octahedral. Got it? I hope it is clear.
Yes, sir.
These three you must remember. Also, if we get back to our original compounds, which Warner used to illustrate its theory, you can see here that this is 1:3. Okay. Sometimes they give the ions, how many ions are forming. They give the ratio of cation and anion, and they write electrolyte. One is to three electrolyte. This is 1:2 electrolyte. This is 1:1 electrolyte. So you can also be given hint in the question in this manner. Okay. And this is not an electrolyte at all, the last option, because it is not getting ionized at all. I hope this is clear to you.
Yes.
So now start with this. We will do some questions on the Varna theory. Okay. Very simple questions. Don't make any mistake, whether it is your CBSE exam or it is your NEET exam or JEE mains or JEE advanced. You have to read the question very carefully in CBSE or in any examination. If you have a question on Varna theory, I'm sure you can answer it if you remain alert, right? And don't make any silly mistake with respect to the charges and all. Okay. So let's let me take some examples. So you can tell me what is the primary valency and what is the secondary valence. Got it? And also you can tell me the number of moles of AgCl precipitated with AgNO3. Got it?
Yes.
So very important question and very basic also. So let's start to figure out what is the primary valence. This is the most easiest to figure out. That will be equal to the charge of the metal ion.
So primary valency is also true
Primary
for
valence
the
is 2. That is the charge of palladium.
yes.
And secondary valence is
For
it's
the
6.
4 moles of
Either it will be 4 or 6. Okay. For you. 5 and all will not be given. Okay, as I told you, that you will be provided mostly with either these two examples, 4 or 6. Got it? Though it is not always 4 and 6, but for NCRT, they mainly focus on 4 and 6 only. So either 4 or 6. Got it? So if you have more ions, right, than this, right, then you can either put 4 or 6, right? So suppose if it is +2, platinum, palladium, it is +2, then you can write the secondary valency is 4. And if the platinum, palladium is +4, then it is +6. Then it is 6. Secondary valency is 6. Got it? What I'm trying to explain. If it is
So can you
+2,
repeat?
if it is +2, secondary is 4 for PTPD. Got it? Generally, if it is +4, the primary valency, the secondary valency is going to be +6. That is only for platinum and palladium. Clear? So this is 4, this is +2. Got it?
Yes.
So the secondary valency is 4. It will be either 4 or 6. Okay, if it is 2, then it is 4. Okay. Nickel is primary valency is 2 and secondary valency is 6. Okay. The rule which I told, that is only for platinum and palladium. Is it clear? Any doubts? For example, if you have platinum is +2, so primary valency is 2. Got it? And what
Yes.
is the secondary valency? If it is 2, it is going to be 4. Right. Look at these two examples. What is the primary valency? Jasleen, what is the primary valency? In this case, it is 4. So this is 6. Got it? This you have to remember for PT and PD. What is the primary valency? Aisha, Jasleen, both of you tell me.
4. 4.
Yeah, 4. Secondary valency. If it is 4, then secondary should be 6. Okay. Normally it happens, but not always. Generally, you can figure it out like this. For platinum and cobalt, this is 3 and this is 6. Is it clear or not? Any doubts, Aisha, Jasleen, in any of these examples? Now write the formula in a square bracket and try to figure out how many chloride ions are ionizable and how many moles of AgCl are going to get precipitated. In the first case, tell me.
So 2 plus
Yes, 4 secondary valency means 4 ammonia are going to be inside, 2 chloride are going to be outside. So they are going to secondary valency is 4 and 4 ammonia are there exclusively to satisfy. So where this Cl minus should stay, they should stay outside the square bracket. And you are going to have 2 moles of AgCl. Got it? Is it clear or not? What about the next one? Suppose if the secondary valency is any number and if you have the same number of neutral molecules, so put that neutral molecules in place of secondary valency. Put all those neutral molecules, and if the neutral molecules are less in number, put the ions also. Remaining ions are actually ionizable. So 6, and we have 6 neutral molecules. Got it? So this Cl
Yes,
minus will be ionizable. Okay, they can ionize, they can go out. So it is going to give 2 moles of AgCl. What about this one?
zero because the neutral.
The overall charges, right? And the secondary valency was 4, but there were only 2 NH3 molecules, so 2 Cl minus should get into the square bracket. Yes, and so no AgCl will be precipitated. Got it? What about this?
Yeah.
PtCl4 and 2 NH3. The primary valency is 4, secondary is 6. Okay. But we do not have 6 ammonia molecules, so we take all of them and 0. Is it clear, Jasleen? Any doubts?
No,
This
sir.
is 6. all the 6 ions are going to come inside. So no chloride ions will be precipitated. Similarly, you have 6, so 4 and 2 chloride ion will satisfy the secondary valency. Means 6, 4 NH3 and 2 chloride. So what happened to that single chloride ion? That should remain out, okay, of the square bracket, and that is only ionism. Is it clear or not? Any doubts in this?
No, sir.
Jasleen, is it clear?
Yes, sir.
Okay. So you should use these terms. These are very common questions. Okay. They ask you to compare the moles of precipitate form. Okay. So the primary valency, if it is 6, either you should have 6 neutral molecules which you are going to place inside, or you can have the 4 neutral molecules and 2 ions, and those 2 ions will not be ionized now because they are now satisfying the secondary valence. Got it? So this is a very, very important part of the coordination compound. The next part is let's do one question. The question is actually the one which we have seen above, but asked in a new way. Okay, this question is also very common. Aqueous solution containing 1 mole. Separately, you need to consider them. Okay. Option A, decreasing order of their electrical conductivity of their aqueous solutions, each containing 1 mole of these ions. So can you arrange them in decreasing electrical conductivity? Decreasing order of electrical conductivity. Who is going to decide the electrical conductivity? How the electricity get conducted by the means of ions, right? So if you have more ions, more electrical conductivity. Got it? More charge, more electrical conductivity. So now tell me, what will be the order of the electrical conductivities? Aisha, Jaslin, which one is the most conducting?
So the first one, because
Yeah, first one
total
will
ions
have
for the primary
total 4 ions.
valence.
Exactly. Yes. So A, then B is actually 1:2 electrolyte. Got it? And C is 1:1 electrolyte. Got it?
Yes, sir.
And D will not conduct electricity. Is it clear? Any doubts in this? Anything if it is not clear? These are some common questions. They will also ask you the moles of AgCl precipitated. A will form 3, B will form 2, C will form 1, and D will not give any moles of AgCl. Right? So next is the next part of this theory is the valence bond theory. Clear? What is this valence bond theory? Any idea? VBT. So what this VBT is all about?
Valence bond theory.
Yeah, this is the same theory which we discussed in class 11. And that explains how bonding happens between the metal atom and its ligand. So we are going to study it again. Okay. So now from the perspective of coordination compounds. Okay. So how can we use this valence bond theory to derive the structures of the coordination compounds? Okay. So basically, as per this theory, Central metal atom or ion uses its outer S, P, and D orbitals. I should add one word also to form bonds with the ligands. Got it? Central metal atom or ion uses its outer empty S, P, and D orbitals to form bond with its ligand. They must be empty. Why they must be empty? Any idea about it? Aisha, Justine, tell me why they must be empty. Why the orbitals must be empty? Because they have to bind with the ligands. They have to accept their lone pairs. Are you getting my point? So these empty orbitals and the filled lone pairs, they overlap with each other. And that's how our coordinate covalent bonds are formed between the central metal atom or ion and its ligands. Is it clear or not? Just first try to figure out